Okay, let's go ahead and get started today. My name is John Belcom. I'm a part of the development team here at Traverse PC. I'm also an LS, and I'm always happy to talk to folks about surfaces in Traverse PC. Now, some of you are attending the webinar today for continuing education credits, and I want to direct you to this page on our website, kind of how it works. During the presentation today, I'll be presenting a 3-digit code, one character at a time. I'll pause when I do that and remind you to write that down. At the end of the seminar, then, you can apply for a certificate, but you'll need that code to verify that you were there. Okay, I want to show you the outline that was on the web. This is our June webinar, and we want to cover services because we get a lot of interest in that. When I go out and do a site survey, it's amazing how many times I'm picking up all the utilities, plus all the topography, plus all the found monuments, just kind of a one pass through there. And I want it to be really fast to collect the points for the topo and then to create that once I come in the office. So fewer points, better modeling, really fast. That's kind of what we're after here today. In Traverse PC, we say surfaces are wickedly simple. And I think you'll walk away going, wow, I see why they say that. In just a couple of topos, you'll get how it works. In our office, the crew that does the field work does the drawing. So they learn to model the surface in the field and let Traverse PC draw it in the office. So we're going to kind of get there. Now, I'm going to be looking at 3 separate surveys today. One to kind of give you an overview. A second one to jump into some more advanced topics on surface modeling. And then a third survey to talk about some construction issues with volumes, grading, drainage, that sort of thing. The surface modeling example is actually one of our sample surveys. And so you'll be able to come back, load that up, walk back through pieces of the webinar here, and kind of learn how that works. So let's take a look at a sample survey. I always like to start with a project so we can kind of walk through the pieces of it, and you can kind of see where we're going before we jump into the details. So I've got a drawing up here called Site. It's a project I did for Caitlin Stone. The Stone family are good friends. Grandpa and Grandma years ago bought a nice big piece of property just east of town, overlooks the river. They parceled it out to some of their kids. So Caitlin's parents live in this house right here. Grandpa and Grandma lived up above, a little higher. And now Caitlin and Allison and some of the other kids have got these pieces of property. And Caitlin's ready to start building on hers. So the family called and said, hey, would you do the topo for the project, locate the utilities, get the information to the architect? And I was happy to do that for them. So let's just walk through kind of what this job did and get you a feel for it. So first thing I did was I went ahead and I'm going to just go to this point plot drawing here instead, just to kind of simplify what we're showing you. So we're not digging through all the pieces there. First thing is that I went ahead and established an elevation out there. We're not doing any FEMA certificates or anything like that, so I just need to have a benchmark that everyone can use. So I chose this property corner up here. I think it was a nail in the pavement up there, and got an elevation from Google Earth. So everyone knows that we're using an assumed elevation of 52 feet at the northeast corner of the lot. Now, real easy for me to use another benchmark and just translate all of this up or down to match another benchmark if we ever determine we need that. The other thing is that I'm walking around on the sand here. It's pretty steep. So if I've got good elevations within a couple of tenths of a foot, that's as good as we're going to get. Every time I walk, I move the sand. Every time the wind blows, the sand moves. So we're going to be happy with that. Traverse PC doesn't really care what equipment you use when you come out and do this survey. You can be out here with GPS. You can be out here with a robotics level station. It doesn't matter. Whatever you can do to pick up the points. All we need are a few points and their elevations out here to model this. And then let's just talk about the deliverables real quick. Go back to the site survey. I went ahead and said, okay, let's send out a PDF to the family and to the architect. And now they've got something that they can go out and give to the city, to the planning department, to start talking about this project. So as quickly as I can say print, I'm going to use the Traverse PC PDF driver that comes with the program. Traverse PC prints out a PDF of the project. And now I can turn this into Caitlin and the architect. And they go ahead and print this out on 8.5 by 11. Won't be to scale, but it's got the scale on there so they can measure it and come up with whatever they want. Okay. I also went into the file export and wrote just an ASCII file of the entire survey. I picked the format that I want, comma delimited, northing, easting elevation, and then I just said, go ahead and export that. Okay. Overwrite the existing file, send out 72 points. So the architect now has everything. Primarily interested in the utilities, any vegetative features like trees and stuff he has to work around, and then he's got all of my topo points as well. And then the final thing I did was I went ahead and sent this out to Dwg Files. Let's go ahead and export this. We're going to choose AutoCAD DWG. In the settings, the only thing I need to make sure I turn on are the 3D lines. I don't need that for the surface, but if I have any additional property lines or anything in there like that, I'll want that. Now, the neat thing about writing this out is that Traverse PC is writing out a polyface mesh to AutoCAD. So in addition to the surfaces and stuff that Traverse PC generated, I'm also setting out the model to whoever is getting this. Okay, so they're getting everything that I started out that I have inside of Traverse PC. Here you can see the road. River's just the other side of it here. Now, the great thing about this is that let's go ahead and tell AutoCAD we want to zoom a window here. I now have the ability to come in and work with this in 3D. So here's my 3D surface up here. Everything else in the background is just at 0 elevation because I haven't used elevations on that. You know, it's real easy for me to come in and just turn those off. But here's everything the architect needs now. Now, if I want, I can also come in and turn on the polyface mesh for that. Let's go up to layers here. And let's just clean this up a little bit. Let's turn off the background, turn off the 0 layer. Let's turn off, there we go. I'll leave the property lines on there. And then let's turn on the polyface mesh. I want you to see that really quick here. So here is everything that that the architect might want to actually come in and work with that surface. And I want you to see that in addition to the pretty picture from Traverse PC, they're also getting a lot of information about this project in CAD terms. So everything they pretty much need from CAD, they're getting here. Okay. So now that we've created that, the deliverables for that, I want to kind of just walk you back through this process, and let's talk about kind of what the pieces are here and how this works. So I'm going to come into this surface, okay, and I'm going to delete it. Let's highlight it, just get rid of it. And let's start over and kind of see how this works. If we go back to our outline here, we're going to start talking about the source, the border, and the tint. Let's cover those topics here first. So to create this surface, and I find myself doing this a lot, I go to the traverse that has the topo points in it, okay? And in Traverse PC, it's only points designated as topo points to get included in the surface. So if I'm picking up the top of a fire hydrant that's 3 feet off the ground, that's not a topo point. So I use the ground shots, designate those as topo. When I create a surface from a traverse, using this command right here, create surface from the selected traverse, Traverse PC does two things for me that are helpful. One is it goes ahead and designates these points as topo for me automatically. Now I can come in later on and turn points on or off, however I want to do that. It also sets the source of the surface to the points in that traverse. Now I could say, I want to use all the points in the survey that lie within a border, like the property boundary here. But I find myself generally using a traverse for the source because now I can have a different traverse for a different surface, and I can compare the two surfaces to get a volume, for instance. So just kind of what I gravitate to. Traverse BC, then, since it has the topo points and it has the source, goes ahead and computes the surface. And that's why we say it's just wickedly simple. I mean, right there you see it just go boom, and I've got my surface. The tin now got created in the process, and if I want, I can turn that on and draw it. Okay, so it looks like that polyface mesh that we just saw over in AutoCAD. Now, for a simple surface like this, I'm not even going to turn the tin on because I can do all my editing just right off the contours here. I want to reinforce the fact that Traverse BC designated topo points. Here's a command that says delineate the topo points in the project. So now I can come in and say, okay, these are all the shots that have elevations on them. But watch how easy it is for me to come in and change that. I'm going to come in and say, okay, this point here wasn't a topo point. It was something else I picked up out there. So I go to right-click it, okay, and I'm going to say topo off. So I just turn the topo off for that point. Now, the surface can be set up to recompute automatically or manually. I think this one was set to manually. So we can come back in and we can say, okay, go to Surface Tools and to recompute that for me. See how it changes? I can also go into the surface, and I can tell the surface under Advanced that I want to turn off the manual compute. So now I can come back and I can say, oh, that should have been a topo point. Puts it in. And I can individually then select points and turn the topo on and off. That's just kind of, I don't know. I just think it's kind of absolutely amazing. I don't know of any place else I could do something like that. Okay, now I want to talk to you about the border here. If we turn the tin back on, we can see it more easily, but you can see the border just comes here along the contours, and it's outside the property lines. So one of the rules that we realize pretty quickly when we start doing topos is that we need to have good definition of the surface at its edges. In particular, we don't want any long, skinny triangles along the edge that make the surface do wonky things. So I generally like to extend the surface outside of the property that I'm surveying. So any edge conditions happen out here. And then I let Traverse BC generate sort of a default border for me. And when I was into this surface, I have the opportunity to select a traverse that further defines the border. But if it's set to none, Traverse BC just kind of does its own default thing. And that's what creates this border for me out here, using all the points that were in that traverse, because that's the source for the surface. So I just want to mention here that I'm often going to work beyond the property boundaries if possible. Okay. Then let's talk about the tin some more. If I come back in and turn this on, and I'm going to draw the break lines, I'm going to draw them the solid line and go just a little thicker here. Let's do a different color here. I want this to show up a little bit better. Okay, let's do a blue here. So here's my tin. The rules on a tin are that Traverse BC tries to create as many equilateral triangles as it can. It's got a lot of other rules as far as how the tin gets developed, but it's basically the tin then that is modeling the surface. And the tin is comprised of these topo points. So I learned pretty quickly that I can come in and model a surface without too many points. And that's part of what makes this work for me so well. Now, I'm pretty quick to, while I'm out in the field, collect traverses like this, B1, 2, and 3. These are break lines. And the only reason I have them out there is to show that they're break lines. Let's go ahead and do some settings on these so we can see them a little bit better. Control point. Okay, I don't need to show anything here. Don't need to label the points. Let's use a dashed line of some kind. Okay, So here's a break line up here, here's a break line up here, break line up here. Well, that's what I'm going to do. I'm going to tell the surface, just by going in here, that I want to get those traverses as break lines. So Traverse BC just went to these traverses I had selected, and it brought in the courses as break lines, and I'm going to apply those to my surface. And we're not going to see a lot of change here, but Traverse BC is going to redraw those now as it's got break lines right here, break lines here, and really all I'm doing, I'm picking up the top of a slope, the toe of a slope. Here I've got the toe of this slope, the top of this slope, and that kind of further defines this little bit of a bench in here. And I don't need very many of those break line points to get exactly what I want out here to model this surface. And we'll take a little bit better look at that when we get into the next section on modeling a surface. But I just wanted you to see real quick how it's so easy to bring those in as well. Okay, let's take a look at our outline. Let's skip volumes, skip exclusions right now. Let's do a little work on slope analysis as we look at the surface overview. So I'm going to leave the 10 on, and let's go back into this surface. I'm going to turn off the break lines. They don't need those now. We'll apply that. Okay. So let's take a look at slope analysis. Slope analysis says, hey, the city has some requirements on foundations or on septic or on whatever based on the slopes out here. And I'd like to map those. So watch what I'm going to do. I'm going to say anything up to 15%, I can change that. I want to draw in a light blue. I'm going to make this a little more solid just so you can kind of see that here. Anything that's up to 30%, this light green, and up to 45%, this light yellow. And I've got a pink up to 60%. So let's see what we get here. I'm going to go 30 on all of these. I'm going to tell Traverse BC, include the slope shading in the drawing. Okay, and I can also include it in the legend. And I'm going to hit compute. Okay, so Traverse BC went in and computed all of the area from 0 to 15, 15 to 30, 30 to 45, 45 to 60. Okay, and I've even got a little bit over 60%. That's kind of interesting. So let's go ahead and apply that. Look what Traverse BC did. It came in and shaded all that in for me, and then I can just print a summary of this. Okay, and now I've got a report view that shows me what all those areas are, plus I've got it shaded on the drawing, plus I can add a legend. I automatically put all these shadings into the legend that tell me what the percentage slopes are. So really, really simple to even do slope analysis in Traverse BC. And again, part of why we say it's wickedly simple. Okay, let's stop there with the first one and call that good for our surface overview. Let me bring on the code then, our first code for the seminar. It's the letter R. While we're doing that, I'll bring Traverse BC over here and load up our next survey. Okay, let me pull that back off, and let's take a look at surface modeling. I'm going to bring up a sample file called Learn Advanced Contours, and we're going to take a look at putting in break lines, exclusions, smoothing contours, and exporting that to CAD. So this is part of one of the site survey samples that comes with Traverse BC. These are the topo points that we collected in a traverse here called, conveniently, topo points. So that's what's drawing those points. Do you remember before that we came in and we said delineate topo points on or off? Okay, so we don't have any topo points in there, but let's kind of walk through the same steps we walked through before with the previous one. So we're going to come in and say, okay, I want to go to this traverse. I want to create surface for the selected traverse, and boom, I've got it. Now, I can also come to the Surface Manager and add a new surface and then select the source traverse from that. That's fine. I just find myself going to this Traverse Manager quite a bit to do that. Now, so we've got the topo points in here. We've got a topo kind of ready to go. I'm going to just turn this off for a moment. And let's turn on boundary here that we're working with. And we can see that this is actually the edge of a road up here. So I don't really need to model that road. I've got a lake down here, and my contours are running out into the lake, and I don't really want to show that. So this gives us an opportunity to talk about using a border with a surface. So in the previous example, we let Traverse BC just kind of stretch a rubber band around all the points and call it good. In this project, we want to actually do a little more work with this border. So what I'm going to do is I'm going to tell Traverse BC I want to copy this thing. Okay, so we just made a copy of it. And now I want to come in and just call this surface border. I'm only going to have one surface in here, so I don't need to, say it's the existing ground border or finished grade border or anything like that. And then let's just change the way Traverse BC draws that. So let's use a darker color here we can look at easily. I really don't need any distance, direction, that sort of thing. I do want to have some points in there just for the fun of it, but pretty small. And I don't think I even care about labeling them, but that's okay. Okay, then let's turn off the original border, and here's our surface border. Now, I'm going to go into the surface, and I'm going to tell the surface, I want to further define this surface by selecting the border to limit it to. So look at, in the Surface tab, right here, I can select a border traverse. Let's open that up. Here's our surface border. Let's apply that. Okay, see how that cleaned us up right away? And now we've got a surface that really models just what we're after here. Now I can further come in and say, okay, around some of these edges, I want to make sure it's doing exactly what I want it to do. So I'm going to zoom in here pretty tight. I don't know how many of you know about this zoom points. I use that all the time for this sort of thing. If I've got point labels and lines zoomed, which is how they would be when I go to print it, everything's kind of overlapped. If I turn this zoom off, now I can pick things individually, and I like that better. So let's say that I just want to model this a little differently down here, and I want to bring this border into 232 and 226. Watch how I do that. Okay, I'm going to right-click any contour or tint, any part of that surface, and I've got the surface tools down here. And the command I want is edit border. There we go. Now I'm going to follow the prompt down here. It just says left-click points to be inserted or deleted. So I'm going to left-click 232, and it inserted that in the border. And left-click 236, and it inserted that. If I didn't get the change I wanted, or I really don't need that, I left-click it again, and it moves it out. So super, super easy for me to just work my way around here and make sure that my edge conditions all look really good. Some of you use the little mouse thing like that. I just press the wheel in. I don't know if you know about that. Kind of handy sometimes. Or you can use the slide bar here. That's fine. And I'm just looking at all the points here that got picked up. Those look pretty good. That looks good. It picked up the 120. Okay, I may have wanted it to come up to 102 instead of 103. Okay, so I could put 102 in, take 103 out. Okay, but that might have given me an edge condition I didn't want. So, I can play around with that, get exactly what I want. And then when I'm all comfortable with it, I just right-click and I'm done. So now I have modified my border. And did it just lickety-split, and I made all those changes in the surface border traverse. So it's not like I made the changes and if I do something, quick, it'll be gone, like in CAD. No, I've actually stored it in the surface border, and I've defined that border. Now I don't have to have it on for the surface to show. I can turn that off, and that's just fine. Okay, next one here. Now let's talk about break lines and how those work. So this particular project, I can see that I've got this sort of flat building area down here, and this is where the little house went in eventually, kind of long, with nice views of the lake. And there was an old kind of access service road here that wasn't built all the way up, so there's some road construction to do up here. But I want to model what was already here because it's a pretty good cut. So watch what I'm going to do. I'm going to go into the turn off that point zoom first. That makes all the lines thinner. And then I'm going to go into the surface. And for our sake here, I'm going to go into contours and tell it, no, I don't need to draw the minor ones. All I need are the major contours there. That's good enough. And then I want to turn on the tin. And I want to draw the break lines so you can kind of see what's going on here. Now, what I want to model is, it looks like this west edge of the road is following just fine. See how this triangle has a line, and a line? That's exactly what that road was doing. Okay, so this west edge looks good. The east edge doesn't. So the east edge, I come off the paved road up here. I've got a triangle edge down here, but I've got a north and south triangle here when I really should have an east and west. So I model that by putting in a break line. So I'm going to right click. I'm going to go to Surface Tools, like I've been doing quite a bit of. I'm going to go to Break Lines, and I want to do this thing. It says Edit Break Lines. Now, if I don't have Automatic Compute turned on for the surface, Traverse BC will ask me, but this one is already turned on. So now I'm going to come in, I'm going to say, follow the prompt. Oops, do this again. Surface Tools, Break Lines, Edit Break Lines. Okay, there it says. Would you like this service to recompute as you edit it? And I'm going to say yes, because I want you to see this. Then I follow the prompts down here. It just says left click, point symbols, labels, or tin lines to add break lines. Left click break lines to delete them. So I'm going to add a break line by clicking from this point to this point, and Traverse BC put in the break line and changed the surface. So I'm making the surface do what I want it to by editing those triangles there. So now you see I have east-west triangles, one triangle that's in the road, another triangle east of it that's up on the slope. And I just walk down through the rest of this. I've got a triangle here, that looks good. Okay, and the rest of this is modeled just fine. So I really only needed to add that one break line up here to create just what I wanted to for the road. So I can right-click now, and I'm done. Let's come over to another part of the project here. And let's talk about something that's going on over here on the east end. So on the east end over here, and I'll turn the minor contours back on here. Kind of makes it just a little more dramatic. I've got an access that's coming down to another piece of property. Holman owns property down here, and there's a driveway that runs over this property. And I want to show that on here, in addition to tying down the driveway for trespass or issues like that. I also want to just have it look a little bit better. So that's over here in a traverse called Holman Driveway. Let's go ahead and turn that on. So the driveway starts up here and runs straight down the hill. Well, it's modeled pretty well right here with these triangles, but not so well up here. So I would like to add that traverse to the break lines. I didn't start out taking this as a break line traverse. I was just picking up the edge of a driveway. So not like the previous example where I did B1, B2, B3. This is just a traverse I picked up for another reason as part of the site work. But I think now I can use it to better model. So let's see what that looks like. And I'm going to zoom in here just a little bit tighter for us. Okay. So I'm going to right-click a break line, or a contour line. Let's go to Surface Tools, Break Lines. And I want this command now, get break lines from existing traverse. So I select the command, and Traverse BC says left-click the source traverse. So all I have to do is come up and click anything that's drawn by Holman Driveway, and watch what happens. Wow. Wow. To me, that's just kind of amazing. You know, that's exactly what I want to have happen there. Okay, I'm going to right-click to end that command, and this is something just kind of neat. I can tell Traverse PC anytime with break lines that keep the break lines in here, but redraw the surface without applying them. So that's what it looked like. Or I can say, the break lines are already in here, so reapply them and draw the surface. And what a difference it makes. So I'm modeling this through the use of break lines. I know I've got another section up over here that's kind of similar. I think about here. And I picked up some retaining walls here. Retaining wall 1 through retaining wall 4. Okay. And look what happens here. I've got triangles and contours running through this retaining wall. So I need to do the same thing here. Again, I didn't pick it up per se as a break line traverse. I picked it up to show that there's a retaining wall here. But I also shot the retaining wall at the ground. Okay, I could have done both, in which case I would have a traverse or the points for just the ground intersection of that retaining wall. But let's just do the same thing we just did. So I'm going to right-click anything that's part of the surface, Surface Tools, Break Lines, Get from Traverse, and I'm going to just pick that traverse. Wow, just brought me right in exactly where I want to be. Okay, now I can do the same thing with this rock wall if I want. I don't think it's going to, okay, change the contours a little bit there. Do the same thing with this one up here. Retaining wall 2. Probably not going to get a lot of change with that. Retaining wall. And I think I've got one more up here. Nope. Okay. So I'm going to right click and tell it I'm done. And I have just done a better job of modeling this Holman driveway over here on the east side, the access into the property from the existing paved road, and some retaining walls here, and done it just in a matter of minutes. So now let's come in and take a look at exclusions real quick. Taking a look at break lines from out of the surface. Let's take a look at exclusions. Now I'm going to zoom in here, leave the triangles on, and let's turn on a covered trailer area here. Okay, and to zoom those points back out. So we've got a covered trailer area here, and we've got contours running through it. A lot of times what we want to do is we want to show that the contours aren't in there. Okay, if it's a foundation particularly, and we don't want to see these. In prior versions of Traverse PC, we had to fill the trailer cover traverse and then put the contour lines behind them in drawing order, and that created a nice visual for us. But it's easier for us now in 2018 Release 1 to just exclude this. Let me show you how that works. I'm going to right-click this contour line again. It could be a tin line also. Surface Tools, and I'm going to go to Exclusions. So I can actually get exclusions from an existing traverse, just like we got the break lines. And I just say, that's the command I want. I come in and pick that traverse, okay, that trailer cover traverse, and the contour lines are out. I'm done. Pretty simple, okay? So now I don't have to worry about filling that or doing anything else with it. The contours and the tin rearrange themselves to exclude that. There's also a shed over here, and it's going to work a little bit differently. So let's drop over here to the shed and zoom in. It's going to work a little bit differently because the shed only has 3 of its corners topoed. This 4th corner over here doesn't have topo with it. So let's do the same command we did earlier. This time I'm going to right-click a tin line. Maybe that's a minor contour. I think it's a minor contour. Surface Tools, Exclusions. Exclusions from existing traverse. Let's pick our traverse here. Shed. Oh, see how it only brought out part of the shed because I've got topo points here, here, and here, so it's able to fix that for me, but not this. I still have this whole other triangle here that's being included. I should probably pick a little bit different color for the minor contours. because that gray is kind of competing with the tin lines. Let's just use a sky blue or something like that. Okay, so now I can see here's the triangle I need to exclude. So let's do the same thing again. Let's right-click, Surface Tools, Exclusions, but this time I'm going to edit the exclusions. So again, Traverse PC says, do you want me to recompute as you edit? I'm going to say yes. And then I look at the prompt at the bottom. It says left-click inside any triangle to show or hide it. So I'm going to left-click inside this triangle, and now it's gone. Now I'm going to right-click to tell it I'm all done so we can talk about it. The exclusion didn't fit the building corner. It fit the triangle that was here. So I'm not going to get any contours in any of that triangle. That's as close as I can get. And I'm going to say it's good enough. I should have picked up this other building corner here. It's not exactly level here. Project and put an elevation in here and make that a topo point. That would work as well. So I could go into this traverse here. I'm at this point right here. I could come in and assign an elevation of that was close and make that a topo point, and then I could go right to that corner if I wanted. But I don't have to. For what I'm doing, that's plenty good. So I've got 2 excluded areas here ready to go. Now, we're ready to send this over to CAD and see what it looks like. And, oh, smoothing. Let's go ahead and smooth next. Let's zoom in here. And I'm going to turn the zoom points off because I want those just a little thinner for you to see. Okay, what I want you to notice, and I'll just pick an area here, is that I've got these sharp angles to the traverses. And I just turned that tin off, but I want to turn it back on. Because the Traverse PC says, I know the elevations at the end of each tin line, so I can interpolate from end to end. So I know an elevation along the line where the contour is, where it's 65 feet. I don't know what the elevation is from here to the next triangle edge, and again to the next triangle edge. So when I hit one of these edges, I have to make an abrupt change to where the next edge is at 65 feet. And we call these engineering contours. So they're accurate. They're right exactly where I want them to be, and I know that the elevations are accurate there, but I get this kind of angled look to it. So it doesn't necessarily really model well what's out there on the ground. So what I want to do is go into Traverse PC. I'm going to turn those tin lines off again, and let's take a look at the Contours tab here. I have the option down here to smooth those. So I'm going to turn on Curve Fitting and apply that. Okay, see what it did? Traverse PC said, I'm going to put in splines so that the curve that results for the contour still intersects the triangle edge at that 65-foot elevation. I haven't changed that. I'm going to modify what happens in between with a spline here so that it turns out smooth. Now, a 1 foot or a 1.0 tension says I can modify that position up to a full contour interval. If I choose half, Traverse PC is going to modify it a little less. And do you see that kind of just flip down here a little bit? So I can go to 1, enter. Okay, and I get that look. I can go to 0.5, get this look. Okay, just a little difference there. The maximum angle just says if I've got an angle of incident as the contour goes through a tin line that is greater than 170, don't bother to do anything. Okay, it's just a flat angle. And then it's really up to you whether you want to turn on this contour smoothing or not, and what kind of tension you want to give that. Let's go ahead and write this out one more time, like we did earlier. Export to CAD. Let's preview that. Now, when we did the exclusions, Traverse PC is going to honor those exclusions in the polyface mesh that goes to CAD. It's going to honor those in the LandXML files that we read and write to Civil 3D. And so I'm going to see those same exclusions here in Traverse PC. Let's go ahead and do what we did before. We actually go out and just kind of see what we've done out here. Here's that road coming in. You can see kind of the flat bench where we're going to build. And because I included the building pad, that trailer covered area, you're seeing it here. And again, no surfaces through contours through that. Can't remember where my shed was down over here. I could zoom in and see that. But I want to come in and turn on the polyface mesh now so you can kind of see what that looks like. Let's turn that one on. Let's turn off the zero layer. So that stuff goes away. You don't have to be looking at that. Okay, and now we can see, just like we would expect, that we also don't have triangles in there. Let's just take a look at that again here real quick. Okay, see how we don't have triangles or contours in that building pad there? We got just what we wanted. Also notice that the smooth contours came over. Okay, so I still have the triangle edges, and they're still doing everything they're supposed to do, but I've got these smooth-looking contours here too. And again, we're giving the CAD folks both the contours that Traverse PC generated and the polyface mesh, so they can do whatever they want to with it. So quick export to CAD. Okay, let me go ahead and bring up the next, and let's talk about this project here a little bit. I used this in a previous webinar. It's a parking lot that we're doing. We're still waiting for final approval on the city before we can do subgrade. But I just went in and computed some subgrade volumes so we know how much sand we're going to have left over. And I want to kind of walk you through that process here a little bit so you can kind of see how this works. Now, we started out with a grading and drainage drawing that we sent into the city. Let me go ahead and zoom in here for us. That used an existing ground topo. So that's the blue lines here, so we know what's out there for the sand. And then I drew an A to A transect line and a B to B transect line. And all I did was go into the surface, and you've seen me do this before, surface tools, and I used this create a transect. And I just picked this line. And I want to show you the drawing it created here. So Traverse PC created this dashed line in profile mode. So I'm using station and elevation, distance along the line and elevation. And then I've exaggerated the vertical scale and drawn in kind of what looks like a reasonable grade here. So I know west to east, left to right, that this existing pavement that's already there was at a 1.87. I know the paving guys are going to want a 2% for drainage, so I just extended that 1.87, called it close enough for 2% over there. So west to east, I know I've got about a 2% grade. I did the same thing for the B to B transect, and here I know this. Notice that I've got a little fill down here on the south end. Halfway up, I've got some cut. Over here at the north end, I've got some more fill. So I've got cuts and fills out here, and I'm going to propose a 1.3% north to south. Now, one of the things that's kind of interesting about it is that when I hit this existing pavement, I'm going to find it's actually kind of flat there. So I'm going to have to fit the design to what's actually there for that existing pavement. And if we go back and look at that grading and drainage, this is that existing pavement. So I'm stuck with whatever this edge is as I grade it north to south. And I've got to drop down, you know, put in the rock. And when the pavement, final pavement goes in the new area, it's got to match up with this. So that's kind of a constraint for me. So let's go ahead and take a look at how we actually do this. I'll walk you through the steps. I did this just the other day. It just takes a few minutes. And although Traverse PC is not a design program, we can oftentimes get what we need with Traverse PC. So the first thing I needed to do was create a surface for the finished grade points. And so I went into, created a subgrade section down here, we call those groups, and I created a subgrade drawing like this. And I said, okay, I've got certain things I need to work with here. I've got elevations at the edge of the pavement and at the sidewalk over here that I need to carry across. This is my 2% left to right. And I've got, I'm going to end up with some elevation over here, but I've got an alley here. And beyond the pavement, I've got 5 feet to the property line. So I've got to have my grade up to the pavement. I've got 5 feet to drop down to match this alley grade, and I need to put a fence in there and some landscaping. So about a 2-to-1 slope is great for sand. So in 5 feet of distance, I can drop 2.5 feet if I need to here. So I'm going to keep that in mind. Going to drop on down. Once I get past the existing pavement, I'm going to pull my grades off the top face of curb or the back of the sidewalk here. And I'm going to have 2% left to right, 1.3 north to south. Okay, so what I needed to do, and I just do this manually because I'm still kind of old-fashioned with a lot of this stuff. I just printed this out, and in a few minutes, drew up some grades, some distances, and said, okay, if I'm 35.9 over here on the west edge, I need to be basically 37.7 over here. I can drop a foot easily. If I drop 1 foot and 5, I'd be down at 36.7. And look, it puts me just about at that 36 contour. So I don't even have to drop 2.5 feet. Dropping a foot is good enough. I'm going to come down, same thing here. I need to be about 37.4 here. Played around with a few of them. Again, I drop a foot, and I'm going to be at 36. So again, I'm right there where I need to be at the alley. Did the same thing down here. And I've got about 8 or 9 points now that I can use for my finished grade. Let's take a look at those. Those went down here in my finished grade points. I added in some of the other points on the west side. I have a total of 12. And you saw me do this how many times? I go in and create a surface for that. Okay. And I did this down here in the surfaces. I call this the finished grade. So let me turn off the existing ground, and let me turn on the finished grade. And it looks just like we expect a finished grade to look. Okay. My water is going to flow from the northeast to the southwest. I've got a 2% slope west, a 1.3% slope south, but I've got these existing grades I need to retain on this existing pavement. So that's the little kink that gets put in here. Okay, this is kind of one of the magic parts to this then that I think is kind of neat. I basically said, okay, I've got just a certain part of this project that I need to do subgrade work on. I'm going to retain this pavement here. So I pulled those points into a new pavement traverse. I did that a long time ago back here in the parking. So here's my new pavement, okay? And I needed this for the pavement contractors anyhow. We needed to determine how much pavement we're going to need so we can get a bid item, and the church can put together a budget for this project. Well, I just duplicated that and created this traverse down here called finished grade new pavement. And the reason I duplicated that is I need to come in and play around with this a little bit. So I needed to come in and say I need to do 2 things. One is I want to move these points onto this finished grade surface. So I'm going to leave the X, Y where they are, but I want to put the elevations on that surface. And so I did the transect command. I said right-click, Surface Tools, Transect. Now, the great thing about this is I can left-click a transect object or a traverse. So I just left-clicked this finished grade traverse. And what that did, every place a traverse point was inside a surface triangle, it figured out the exact elevation of that point in that triangle and adjusted the elevation of that point. So that brought every point in this traverse up to that finished grade surface. All I had to do then is come in and match up the grades here at the edge of the existing pavement. Then I said, okay, drop that down 9 inches. 6 inches for rock, 3 inches for pavement. And that's my subgrade. Okay, so out of that I created a surface. Just went to create a surface, boom. Here's my subgrade surface. And I left these in green here because I did green for the subgrade. So you can kind of see here's a half-foot contour, half-foot contour, 1-foot contour. And again, I expect my subgrade to follow the same direction basically as my finished grade. But here's the kind of the beautiful fun part is that now I have 2 surfaces. I have my existing ground surface, which covers the entire project, and I have this subgrade surface, which is just inside this subgrade shaded area green. and I can compute a volume between the two of them, and Traverse PC is smart enough to say, oh, this smaller surface exists within the bigger surface, so it's going to compute all of the necessary intersections of triangles. And in fact, it creates prismoids that are triangles top to bottom, but they've got their own angles to the surface, in this case, between the existing surface at one end and the subgrade surface at the other end. So I just call those a prismoid. And Traverse PC can sometimes compute thousands and thousands of those to exactly pick up every piece between those two surfaces. Of course, you don't see all that as a user. You just come over here, you double click this to bring up the surface. You go to volumes, and this is what you say. You say, I want to compute a volume from the existing surface, which I've called 61417 imported, to the surface, which is the subgrade. And I want to shade those polygons in there. Okay, and I'm going to turn off this traverse here so we can see how those get added. Just like I did for the slope analysis, I'm going to say, if it's a cut, shade it yellow. If it's a fill, shade it blue. If it's the same, I'm not making any changes, just use it light grade, okay? And I want to shade those in the volumes, in the drawing. Let's compute that. Okay, so Traverse PC says, and I'm not going to zoom in here, but I've got a net 278 cubic yards. So I've got 333 cubic yards of cut, 55 cubic yards of fill, and when I apply it, Traverse PC is going to add those to the drawing for me. And I had to hit OK to actually get those there. Now, the other thing I'm going to do real quick is that I've got a report view that Traverse PC is keeping for me, and I use this kind of for chicken tracks. Okay, so I'm going to go back into that surface just by double clicking it, and I already computed this. Oh, I got to go to the surface, subgrade, compute. There's my yardage. I'm going to add a summary. Okay, so the summary now takes that same information and puts it in a report view. So now I've got all my volumes and areas and everything listed here. And I know that I've got about 27 dump trucks of sand left over when we're done. Now I can change the design a little bit. I can raise that east end and waste some material doing that. And maybe I can get it down to 150 cubic yards. Okay, so 15 dump trucks. Now the church has another project where they might be able to use that sand, so I'm going to see if we can just sort of keep that on site and ask Gary to do a little more cat work for the project. But this is all I wanted this for. I just wanted to come in and get a volume here so I knew what kind of excavation we were looking at. And then Gary knows this, but he's going to have a little fill up here. Most of it's going to be cut, and then we're going to waste down here to get the grade that we want, fill this, and then we're going to have some stuff left over. And eventually I'll just turn off that original stuff, and away we go. Okay, let's take a look at our outline again real quick. We took a look at 3 surveys. One was a real simple topo survey for Caitlin Stone, and we walked through the pieces of that. Another one was the Learn Advanced Contouring sample file that Traverse PC ships with, and we looked at modeling and doing break lines, exclusions, and smoothing. And then we took a look at a construction project where we did transects, and we worked toward the grading and drainage that we wanted, and then did volumes for the subgrade work. So a lot to cover in an hour, I know, but I hope you'll walk away from this saying, well, I had no idea Traverse PC could do all that stuff.